This is a little intro to writing chemical equations. Get this balanced here a little bit. So just the first part of this. So a little bit of terminology here. So first of all, a chemical equation represents a chemical reaction. So some things react, make some new things. So equations represent those. So if we have hydrogen and oxygen gas, there are 7 elements, by the way, that are diatomic, that occur as pairs when they're by themselves. So most elements are not in pairs like this. There are 7 of them that are diatomic, but we'll get to those later. So if hydrogen and oxygen react, mix them together, light them on fire a little bit, they form water. So the bonds in the H2s break apart, bonds in the O2s break apart, you make new bonds with hydrogen and oxygen. So in a chemical reaction, you are breaking bonds and making bonds. These things on this side are called the reactants. So some terminology you need to know. This side over here, the things that are reacting, called the reactants. The things that are made or produced are called the products. Okay, and there might be 1, 2, or 3 reactants. There might be 1, 2, 3 products. There could be more than that even. Okay, so reactants, products. This is your equal sign. So these things are forming those. Okay, and that's your equal sign. Equation means equal. Equation means equal. So in a chemical reaction, you can't create or destroy atoms. So you put gas in your car, you burn it, all those atoms are still here on Earth. They didn't change into new atoms. You might make new compounds. Okay, you're making new compounds, but you didn't create new atoms. So however many atoms are over here, you need to have the same number of atoms over here. That also means that whatever this stuff weighs, that's going to have the same mass over there. So that's the law of conservation of mass. So we have to balance the equation out, okay, to make sure the atoms are equal on both sides. Couple other terminology things. That little number is called a subscript. The little 2 there is a subscript. Okay, those are subscripts. Remember, those are telling you the number of atoms you have. So 2 atoms of hydrogen, 1 atom of oxygen, 2 atoms of oxygen here, 2 atoms of hydrogen. So those are called subscripts. So if we think about this reaction, we have a hydrogen molecule reacting with an oxygen molecule, which happens to be double bonded, making water molecules. So here's a water molecule. It's got a bond between that. So again, we are breaking these bonds and remaking those bonds. Reactions always involve breaking bonds and making bonds, so making new things. Well, we have 2 hydrogens involved in the reaction and 2 are made, so that's good. Over here, there's 2 oxygens that were involved and only 1 made. That's not possible. We can't destroy an atom or create new atoms, so we have to equal this out. So there must be 2 oxygens over here. What that means is there must be 2 water molecules made. So I'm going to put in another water molecule. What that means is I'm going to put a 2 out in front of here. That's called a coefficient. Number out in front is called a coefficient. Again, the little number down here is a subscript. That's a coefficient. The subscript tells you how many atoms you have of that element. The coefficient tells you how many molecules you have of that compound. So coefficient is the number of molecules of that compound. We have 2 separate water molecules. They are not connected. It's not H4O2. There's no compound like that. It's 2 separate H2O molecules. Well, if you think about that now doubled our hydrogens. We now have 1, 2, 3, 4 hydrogens. So over here we have to have 4 hydrogens. So we're going to stick a 2 out in front of there, which means there are 2 of these molecules, 2 H2 molecules. So these 2 molecules react with that 1 molecule to make these 2 bigger molecules. Again, all the atoms should be equal. You got 4 hydrogen atoms, 1, 2, 3, 4 hydrogen atoms, 2 oxygen atoms in that 1 molecule, 2 oxygen atoms in those 2 molecules over there. So your number of atoms, individual atoms, have to be equal. Masses would be equal too, just so you know. So if this was 4 grams and this was 32 grams, these would weigh 36 grams. They'd have to add up to that. Those have to be equal. So we'll put a number out in front of here. That is telling you the number of molecules that you have. Okay, number of molecules. I pause you for just a second. All right, let's take a look at this reaction. You have nitrogen molecules and hydrogen molecules making NH3 molecules, what are called ammonia. So let's say we have 1 N2 molecule, so that's 1 molecule, but it's 2 nitrogen atoms. Again, one H2 molecule, 2 hydrogen atoms. Let's put one there. Again, this is your equal sign. So these bonds are being broken. Those bonds are being broken. We're making new bonds between nitrogen and hydrogen over here. Well, you've got 2 nitrogens there and only 1 there. So let's double the number of molecules there. So that gives us 2 nitrogen atoms, but it also gives us 3 hydrogens, and 3 hydrogens gives us 6. Or 2 molecules times 3 hydrogens, 6 hydrogens. So we need to get 6 hydrogens over here. So bump that up. That's now 2, 4. Now we've got 6. So 1 molecule of N2 reacts with 3 molecules of H2, which would be 6 individual atoms of hydrogen, to make 2 molecules of NH3, which is 2 nitrogens and 6 hydrogens altogether. Let's do this. Now we got 2 reactants, 2 products. Again, bonds are being broken in the reactants, bonds are being made in the products. So let's put everything out of 1 right now. We got 1 of each molecule. We have 1 CH4. So let's kind of look at individual atoms here. That's got 1 carbon in it. This has 1 carbon in it. So the carbons look good. We got 4 hydrogens. And over here, there's only 2 hydrogens. So let's make that a 2. Now there's 1, 2, 3, 4 hydrogens. Now let's look at our oxygens. There's 2 oxygens here, 2 oxygens in that molecule, and oxygen there. So there's 4 oxygens on this side of the reaction. 4 oxygens on the right-hand side of the reaction. And we only have 2 in the reactants, so we need to make that there. So 1 molecule of CH4 reacts with 2 molecules of O2, which is 4 total atoms of oxygen. You got 2 atoms of oxygen in that, 2 atoms of oxygen in that, 1 carbon, hydrogens are equal. Let's go back and let's do one more example here, maybe. All right, say we have this reaction. It's called a double replacement reaction. You've got this compound and that compound are the reactants, and they're producing this compound and this compound. Remember, all the atoms have to still be there. You got a magnesium, you got magnesiums over there. You got nitrate or NO3. You still have that NO3 over there. You have phosphorus and oxygen here. You have phosphorus and oxygen here. I will say when we're doing polyatomic ions, I try to do this as a group. Okay, they can't always be done as a group. I try to do them as a group. So what I mean by that is, right there are 2 NO3 groups. 2 of the NO3 groups. Okay, so I try to do those as groups if I can. Let's just start at the beginning. You can kind of start where you want to here. You got 1 magnesium atom. Remember that 2 is just for the stuff in parentheses. You have 1 magnesium atom. And over here we've got 3 magnesium atoms. So I can't just throw a 3 in here. Okay, these get together based on their electrons. But I can put a 3 out in front of here, a coefficient, which means I now have 3 of those individual molecules, MgNO3, MgNO3, MgNO3. Let's look at our nitrate groups. We had 2 of these NO3 groups, and we just tripled it. So there's now 6 of those NO3 groups. There was 2, we tripled it. And over here, there's really only 1 of that NO3 group. So we have 6 of them over here and only 1 there. So I'm going to multiply this by 6. It means you're going to have 6 of those KNO3 molecules. Well, it also gives us 6 potassiums. And right here is only 3 potassiums. So let's double that to give us our 6 potassiums. So 2 times 3 is 6 potassiums. Again, we can do this as a group. There's really 1 of that group, but we've doubled it. So there's now 2 of that group. And right there's 2 of that group. So 3 molecules of MgNO3 react with 2 molecules of K3PO4. They make 1 molecule of Mg3PO4 So you can put a 1 out in front of there, usually like that, and 6 molecules there. All right, that was a quick little balancing. Maybe we'll do one more here real quick. One more. 1 Fe and 2 Fes are made over here. So let's double that. Again, I can't put a 2 after it. The difference between that 2 means there's 2 separate Fes. If there was an Fe with a 2 after it, that would mean there were 2 Fes bonded together. And 2 Fes don't bond together. They both have positive charges, don't want to get together. So that 2 has to go out in front, saying they're 2 separate Fe atoms. We've got 2 oxygens there and 3 oxygens there. Whenever we have 2 and 3, we want to get them to 6. So let's triple this. 3 times 2 is 6. That means I have O2, 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 3 of those molecules. And this needs to be doubled. Well, that also doubled our irons. So 2 times 2 is 4 irons. We're going to change this to a 4. So 4 irons, 4 irons. 3 times 2 is 6 oxygens. 2 times 3, 6 oxygens being produced. That's it.